What's up, coders? Good morning, good afternoon, and good evening. Today, we're going to be doing another Leetcode problem, number 134, gas station. So let's see what it is about. There are n gas stations along a circular route where the amount of gas at the ith station is gas of I. So if we look at example 1's input, we see a gas array here. Each number here indicates how much gas we can pick up at a specific gas station. Now, there's another array called the cost array. This is going to specify how much gas we need to spend to go from one gas station to the next gas station. Our objective here is to find a valid starting gas station that will allow us to complete a round trip across the circle. It is possible that we don't even have a solution. In that case, we should return -1. Now, let's go to the conceptual portion of this explanation. Okay, this is a diagram of example 1 on the Leetcode website. The easiest solution that we can come up with at this point is to do a brute force solution. Now, the brute force solution basically involves testing every single gas station. Each of these could be potential starting gas stations. Let's just simulate the process it takes to go from that potential gas station all the way around until we complete a full circle. If we can complete a full circle without running out of gas, then that means this is our answer. If we actually run out of gas, then that means we move on to testing the next gas station. So here, if 0 didn't work, we would test 1. If 1 didn't work, we would test 2, and so on and so forth until we did the entire thing. Now, this is not the most efficient solution. It is actually quadratic time. We go through all the gas stations, and for each gas station, we go through all the gas stations again. So, there is actually a better linear time solution that we will be discussing today. Now, in order to better understand the linear time solution, we will start with the brute force. Let's say we start at gas station 4 as our starting gas station. We're going to have two variables here, the tank variable and the net fuel variable. For now, we're going to be ignoring the net fuel variable, and we're just going to be focusing on the tank. This is basically how much we have left in our tank as we go through all these different roads. Of course, we start off with an empty tank. Now, at gas station 4, we can actually pick up 5 gas. And then we take the road, which is -2, which leaves us with 3 gas as we enter gas station 0. Now, we do +1, which is 4, and we do -3, which is 1. Now, at 1, we have 1 gas. Now we do +2, which is 3, and then we do -4, which is -1. Now, we have failed. We cannot even reach gas station 2. Now, do we have to start all the way over at gas station 0 and try this round trip process all the way again? We actually don't have to. This is because we know that anything between 4 and 2 is also doomed to fail. Why is this? It is because 0 and 1. If you start at any of these gas stations, we're going to have less gas than we had before. Let me explain why with an example. Let's say we start at gas station 4 again. We have an empty tank at 0. We do +5 -2, which means we have 3 gas as we enter gas station 0. That is 3 extra gas. We want as much gas as possible because that gives us the best chance of finishing a round trip through the circle. But if we don't start at gas station 4, let's say we start at gas station 0 with an empty tank, we do +1 -3, which gives us -2. We fail immediately. Notice that we wouldn't have failed if we had that extra gas surplus from gas station 4. And the same can be said for gas station 1. We start off with an empty tank, we do +2 -4, which is -2, and we can't even reach gas station 2. So now we know that if we start at 4 and fail at 2, anything in between is also going to fail. So we should just skip them. In terms of the algorithm, that means if I fail at gas station I, with I being 1 here, because we can't even go from 1 to 2, right? we should start over at gas station I plus 1. So that means we should start over at 2 in this case. Now, this is the first most important part of our optimized algorithm that is actually linear time. Every time we fail, we can use the knowledge we gained to skip gas stations that we know are going to fail anyway. Now, let us start from the beginning with this much smarter approach and see where it takes us. I'm going to reset this tank variable, and we're going to actually consider an additional variable here called net fuel, and that's also going to be set to 0. What net fuel is going to do is it's going to keep track of all the gas stations and their associated numbers. So for example, we add gas here with +1 and we subtract gas here with -3. All these terms are going to be added together and put into this net fuel variable, and this is going to be important later. The difference between these two variables is that the tank is going to be reset to 0 every time we restart our simulation process, but the net fuel variable is never going to be reset. So let us start from the top with our much smarter approach this time. Let's say we start at gas station 0. We do +1 -3. That means our tank is at -2, net fuel also -2. Now, we're at 1. We do +2 -4. Well, before I actually go and do that, however, we have a problem, right? Because when we went from 0 to 1, we found out that we couldn't even reach 1. So therefore, we're going to start over. According to our algorithm, we reset the tank to 0. We start over from gas station 1, but we never reset the net fuel. Okay, here at gas station 1, we do +2 -4. That is going to be -2 for our tank. And then for our net fuel, it's going to be +2, which is 0, -4, which is going to be -4. Now, we cannot even reach gas station 2. So again, we're going to start over, reset our tank back to 0, and start at gas station 2 this time. We're just following the algorithm I laid out before, the more optimal one. So at gas station 2, we're going to do +3 -5. So that's going to be -2 for the tank. Now, -4 + 3 is going to be -1, -5 is going to be -6. Now, we can't even reach gas station 3, which means we're going to restart the tank, set it to 0, and start at gas station 3 this time. Net fuel never gets reset. Now, at gas station 3, we do +4 -1, which is 3. And then here, we do -6 + 4, which is -2, and then -1, which is -3. Now, we can actually make it to gas station 4 this time, which is great. We are making progress. Now, at gas station 4, we do +5, which is 8, and then we do -2, which is 6. And then we have to update net fuel as well. We do +5, which is going to be 2, and then -2, which is going to be 0. Now, we've come back all the way to gas station 0. Another part of this algorithm is that we don't actually have to go through and finish the round trip and end back at gas station 3, because that's where we started at, right? We don't actually have to do that. We just have to complete one round trip across the circle. Now, there are some complications here, right? I was able to figure out that starting at gas station 3, we never actually failed as we were going back all the way to gas station 0. So gas station 3 is a potential answer for our problem. But since I didn't actually complete the round trip, how do I know that gas station 3 is actually our answer? Well, this is where our net fuel variable comes in. We know that in order to complete a round trip, right, from gas station 3, we have to go through 4, 0, 1, 2, and back to 3, right? That's very obvious. Now, what does that entail? Mathematically, that just entails adding or subtracting the right numbers in the right order until we get back all the way to 3. And that is exactly what we did with this net fuel variable. Now, what does this number actually tell us? Well, if it is greater than or equal to 0, that means we had enough gas to complete the round trip, which means everything is all good. We can return 3 as our answer. If it is less than 0, then that means that we did not have enough gas to complete the round trip. This net fuel variable is very intuitive when you think about it. It basically just keeps track of the amount of gas we have versus the amount of gas we need. And based on whether or not it's greater than or equal to 0, we know whether or not we can complete a round trip. Now, of course, if it is less than 0, we know to return -1 immediately. And it being less than 0 is not just saying that 3 is a bad answer, it's saying all of these other gas stations are also bad answers. Because no matter where you start off with in this circle, you're still going to have to go through the same series of numbers, the same series of additions and subtractions, and get back to the starting point, which is very accurately reflected in this net fuel variable. And regardless of your starting point, if it's negative, that just means you didn't have enough gas to complete the trip. Now, we were able to establish that this is the most optimal solution, and this will in fact give us our true answer. This is a linear time solution because we start off with gas station 0 and we keep going all the way until we go back to 0 at the very end. We never visit a gas station more than once. And we were able to achieve this by just using 2 very clever tricks of ours. Now, that is it for the conceptual overview. Let's go through a coding example. Now, I'm going to very directly translate what we went over in the conceptual portion. We're going to have 2 variables, tank, which is going to be set to 0, and we're going to have net fuel, which is going to be set to 0, and the starting point, that's going to be set to 0. Now, we're just going to literally go through the circle. So for I in range length of gas, this is just iterating through the gas array. And then we're going to say, well, we want to add to our tank gas of I minus cost of I. This is our consumption, right? How much gas we have minus how much gas we have to spend. Net fuel is also going to be the same thing. Remember, these 2 variables are basically the same, but net fuel is never reset. If the tank falls below 0, which means we've run out of gas, what we want to do is reset the tank and then start over with I plus 1. And that is the end of our for loop. Once that whole process completes, we want to do one more simple check. We want to return -1 if the net fuel is less than 0. Otherwise, we can return start. Now, remember what we said. Net fuel less than 0 means that we didn't have enough gas to complete a round trip no matter where we started. Greater than or equal to 0 means that our last starting candidate, that was actually able to complete a round trip. So we just returned that. Let's see if there are any errors here. All right. It looks like we are good. So let's just see if this can run. Okay, so that's accepted. And just to be very clear here, we have linear time, right? And we also have constant space. We are not using any extra space here. We're just using what we're given. All right, that is the end of this video. If you liked it, please like, comment, and subscribe, and I'll see you in the next one.